Everyone. Welcome to the third CS Saturday. If you've been consistent and kept up with all the work of the previous weeks, kudos to you. Today will be the continuation of the previous session where we have covered two pointers. And let us start with the basics of strings. As you might already know, a string is simply a sequence of characters such as letters, numbers, punctuations, or even blank spaces. Strings in many languages are mostly enclosed within double quotes or quotes. And these are a few examples of strings. This is an alphabetical example, hello. And if it is enclosed within double quotes, it is identified as a string. And you can also include numbers in strings, and you can also include special characters. And in most, as we've already mentioned, in most programming languages, strings are enclosed in either double quotes or single quotes. Strings are usually used to represent and manipulate textual data in programs. For example, you might take, instead of numbers, you can assign variables with characters as well. Also, you might get a confusion that if you enclose capital A or small a within uh, double quotes, what will be it taken as, and it is case sensitive, so you might want to be careful with that. And there's also a concept of ASCII values, where the strings have special values. So we can let us take an example of lowercase a, which is the value of 97, and uppercase a, which is a value of 65. So different special cases have different numbers. This is how it is often used in many problems as well. Let us see some basic operation on strings. So some of the basic operations you can perform on string. One is concatenation. Concatenation is nothing but joining two or more strings together. So we have an example here. If you want to, maybe you assigned let us say you took an example of a string, and then you assigned its value as hello, and you might have forgotten to add the word next to it. You can just concatenate it. In Python you can just use a plus symbol, and in C there is a function called concat, which you can use to join two strings. It is nothing but joining it. And then to get the length of a string, there is a function called length. If you add it next to your string after adding length, you will be returned with an integer value, which will give you the length of the string. Here, if you look at the example, there's hello. And if we have used the function of length here, and as we have 5 alphabets in it, the length is returned as 5. Also, you can also access individual characters in a string. So you might have already accessed numbers in an array, right? So say a string is basically the same way. So if you want to index a string, if you take the example of hello here and index it as 0, and it would return you with the alphabet value, which is at the 0th index, which here is hello. And if you take an example of, say, VBIT, and want to access the second alphabet, you would say VBIT of 1, which would be B. And this is a special case in Python, especially, is that it's called slicing. This operation is called slicing. This way, this allows you to extract a particular portion of the string. You might come across many problems while doing DSA, where you are allowed to where you are required to use only a part of the string, or a part of the whole sequence of a sentence you're given with. Then you can use the starting index of the portion you want and the ending index, and then you would get your required answer here. See here, if you look at the example, the starting index in the slicing operation is given as 1, which we know as E here, and the ending index is given as 4, which we know as L here. So we would get a phrase which is ELL. That is how you do the slicing. And if you go from 0 to say 2, you would get HEL, right? I hope you're clear with that. And also, if you have any doubts during any time of the session, please post them in the comments box below. We are very active, and we would love to help you with your doubts. And also, you can find a particular position of a string, of a character in a string. Say you want to find, oh, I don't know what is the position of, say, E in hello. You can use the function find. It is not different languages have different functions for it. If you say you want to find the position of E here, and you use this function, and then it would return as 1. And if you say you want to find the position of O, then it would return uh, as 5, because it has 5 characters in the string. So you might now think that what is the use of point of using all these functions when I can just look at the word which is given, and just know it by myself. What is the point of this function? When the input is particularly small, it is very easy to know your output. It is the same case for every program, right? When as the input increases, you might have like uh, maybe when you join a company, you might have thousands of lines of code where you might want to find a particular portion of the string, where you might want to find how many times a word is repeated. Then all these functions would come very handy. So I hope you concentrate on these strings, and maybe exercise all the functions and work them out for yourself. The thing about DSA is, no matter how many lectures you watch, there's only so much you can learn from just watching a video, right? It's all about practicing on your own. So pick up your favorite language and start working today. So let us see a basic problem in string. So let us take the example of hello itself. You're given hello, and then you're asked to find the reverse of it. So what do you do in such a case? In that case, you would, as you've if you have attended our previous session where we have covered two pointer method, you would know, you might get some kind of idea on how to approach this problem. If you don't, that's fine, we'll cover it here again. So this is a pseudo code. So up, approaching every problem is different, right? You don't directly jump to coding the part itself. First, you understand what the problem is about, you analyze it, then you think about what logic can be used there, and then you write a pseudocode which is language independent. You can write the pseudocode in English or your mother tongue as well, as long as you understand it. And then you can you can dry run the input which is given to you, and then you can all this process would make coding the problem very easy. So I hope you understood that. So let us get into the reversal of a string. So we have a function here which is called reverse string. It would take an input string as a parameter, and it would return the reverse of a string. So here we have used the two pointer method. We have two pointers here called the left pointer and the right pointer, and we have initialized the left pointer to 0 because we want to start traversing the string from the first, and then the right string as input string, length of input string -1, because we don't want to go out of the bound of arrays. And and here we have used a while loop here. We know that loops are are common in every language, whichever language you take. While is same in Python, Java, C++, or C. The syntax is same. The logic of while loop is same. So we've written it in a pseudo code form. And here, while left index is less than right index, as long as left index is less than right index, what we do is we swap both the characters which are present at the respective positions. So what it means is, we'll go back to this hello example here. So it has five alphabets in it, right? So this would be the left pointer, and this would be the right pointer. So what we do is, we know that the left pointer is initialized to 0 and the right pointer is initialized to 4, because the size, because it is initialized as size minus 1, right? Just a second. So yeah, and we have the left position's character as H and the right position's character as O. So what we do now is, we check if the left pointer's index is less than the right pointer's index. So here we know that hello is less, sorry, H is less than O, which is 0 is less than 4. So we go, so the pointer will go into the loop, and then we swap the characters which are at left and right pointers. That means that the H and the O will be swapped. So how exactly do we do that? What is the logic behind swapping two two characters which are at their positions? So what we do is, we take a variable called temp, which is like a temporary variable which can be used to find, to swap two numbers. And then what we do is, we assign the value of the left pointer's character to temp now. So temp here, if we take the example of, if we continue to take the example of hello, would be H, right? And then we go to the next step, and the next step is, we have the left pointer here, and it is assigned with the value of right pointer, as we know here is O. So the left pointer's character value is now O, and the temp's character value is now H. And then we go on to assign the value of temp, which is H, to right. So I think you might be able to follow what is happening here. We have assigned H to temp, and we have assigned O to the left pointer. And then we proceed to assign temp to right. That means that the right has become left now and the left has become right. After this, we increment the pointer which is in the left side position. That means we increment the left pointer. So, and then since we need to move forward in the string, we increment the left pointer and we decrement the right pointer. This is because we need to go backward from the right pointer, sorry. So this process is repeated until, as long as our left pointer's value is less than right pointer. So let us try to dry run this thing, and let me just change my screen. Yeah. Just a second. So let me take H, E, L, L, and O. As you see here, this will be a left pointer. Let me just mark it as L, and this will be a right pointer. Just a second, guys. Just a second. Sorry for the inconvenience. Okay, we are back now. Let us continue. So we have the left and the right pointers here. So this is the left pointer and this is the right pointer, which is assigned with H and O respectively. So we know here that L is equals to 0, right? And R is equals to 5. Sorry, 4. 5 minus 1. Because since from the pseudocode, if you observe the pseudocode here, the right pointer is assigned to the length, assigned with the length of the input string minus 1. This is to make sure that we don't go out of bound, array out of bound. And yeah, let us go back. So yeah, our L value now is 4, and our value is, sorry, L value is 0 and our value is 4. So as we know, as long as just a second, as long as L is less than R, we continue with the while loop, and clearly here L is less than R. So what we do is we swap H and O. So these are the two pointers, L and R. So this is that is why this algorithm is called the two pointer method, which is widely used in reversing strings, array, palindrome string, etc. So we will swap both H and O now. So it would be, oh, sorry, it would be O, E, L, L, and H. So we have this right now, right? So we continue in the, so now the second step is to increment L, right? The second step is to increment L. So L value now would be, L value now would be L, 0 plus 1, which is 1. And R value would be 4 minus 1, just 3. So now we are at E and L. So now we are at E and L, right? This is our L left pointer, and this is our right pointer. So let us check if L is less than R, which it is clearly. 1 is less than 3. So we continue with the while loop and we swap both E and L. Now let us swap. Let us swap it. Just a second. So now it would be O, L, L, E, and H. So you might, so as you can see that we already got the reverse here, but we still have to check the conditions, right? So now we can see, now we can proceed with the increment and decrement of L and R respectively. What do we get now if we increment L now? We get 1 plus 1, which is 2, and then we decrement R, right? 3 minus 1, which is 2. As you can see that L and R become equal here. So there's no need of swapping the characters again. We can just come out of the while loop here and return the string. So we would return the string here, and this is the reversed string of hello. So this is the basic idea behind reversing a string using two pointers. And if you also want to look at the logic of swap function, let us take the function of a swap, which is a comma b. I'm just going to explain you the logic behind it. And we have a temporary variable called temp, right? So we assign it with the value of a first, the first number. You don't need to use semicolon also. And then we assign the value of b to a. And then we assign the value of temp, which is a, to b again. So now we know that a's value is b and b's value is a. Now, if you print A and B again, we would get it as B comma A. So this is how you swap two numbers. This is very important. So yeah, it might be very useful to you to remember this piece of code. And in many languages you have a inbuilt function called swap in Java, in Python, and in C++. You don't even need to write this three extra lines of code. But uh, but you know, since many of you might be from first year, you're taught C language first, so you don't really have many built-in functions in C. So that's why you're normally told the logic behind swapping to integers as well. So yeah, let us go on to code this now. So this is a lead code problem, reversing string. Many of you might be aware of lead code. It is like the most widely used platform for competitive programming. Yeah, so let us get into it. So as I've told you before, you don't just directly jump into writing the code, right? You first read the problem, analyze it, think about what logic can be applied here. You don't need to think about the logic here because we just covered that we will be reversing the string. But normally, don't just directly jump into solving the problem. So let us read the problem statement first. It is saying that write a function that reverses a string. The input string is given as an array of characters S. You must do this by modifying the input array itself. So what it is saying here is you cannot take an extra array. It needs to be completed without using any extra space. That means you cannot declare any new arrays, which would be costing you more space. We will get into time complexity and space complexity in the later session of this video. For now, just know that you cannot use any extra arrays. So yeah, let us look at example 1. Here, as you can see, they gave us an array which is made up of characters, basically, right? A single When a string has only one single element in it, you can call it as a character, and a string can also be defined as a character array in C. If you guys might have studied C, you know that it is defined as a character array in C because you don't really have strings in C, right? So this is just an array filled with different characters. How do we know that it is a character? Because it is enclosed within double quotes. So as we already looked at this example, it is HELLO, and we have to reverse it, which we already did here. We have drive run the code. We just need to code it now. Okay. We have read the problem carefully now. We know what logic to apply, and we've also dry run the code. So we are all good to code it now. Okay. So yeah, now that we've gone through the pseudocode of reversing a string, let us dry run the input. Okay. Now let us consider the example of hello. HELLO. It has 5 characters in the string, so the length of the string is 5. So as we know that we are covering the algorithm of 2 pointers here, so we take L and R, left pointer and right pointer. Okay, and we initialize L to 0, as you've seen in the pseudocode, and R to length of the string minus 1, which is 4, right? And we know that we have a while loop now. We have to check if L is less than R, and clearly 0 is less than 4. So we move on to the next step, which is swapping both the characters which are at L and R's pointers positions respectively. So as you can see, we've swapped 0 and O and H here. And so if you want to look into the logic behind swap, the thing we in swap function we use a temporary variable to swap two integers. we can also swap to like characters or integers, whatever, without using an extra temp, but it is might be a bit confusing for beginners, so let us just do it using a temp variable. So what we do is, first we take a variable called temp, then we assign it to the value it with the value of a, which is one of the characters which want to be swapped. So now the value of temp is a, and then we move on to the next step and we assign the value of b with a. So now if after this step, if you print a, you would actually be getting b because you have assigned it to a. So it will be b now, and then now b is empty, right? We don't have any use for b anymore. So in the next step we assign the value of temp, which is a, with p. If you now print just b after this step, you would get the output as a. So now if we print both a and b, we would get it as b and a. You can it is the same for any two numbers or floating point numbers, integers, anything, or even characters. It is same for the characters as well. So what this is what goes behind like the logic of the swap function. So if you are in first year, you might be your introduction into programming might be with like C language, right? You're probably taught C language first. So what you do is, since many languages like C++, Python, and Java already have inbuilt functions, but C doesn't have it. So we declare the function and then we write the definition for it and then we use it in the program. But if you're using C++ or if you're familiar with Java or Python, you can directly use the swap inbuilt function. So yeah, now that we swapped O and H, let us move on. So we know that from pseudocode, we need to increment L pointer now and decrement right pointer, which is R. So here we have incremented L and decremented R, and we've also checked the condition, which is 1 is less than 3. So now we also uh, swap E and L, and this is what we get uh, the result as L is in E's position and E is in L's position, and we've as you can see that we've gotten the reversal of hello, right? It is HELLO and now it's OLLEH. But many the input varies every time, and you might have like a character which has like 40 a string which has 40 characters in it or whatever. So in such extreme cases, algorithms like this come into play. So yeah, now that let us move on because we are not still done with the increment part. Now we increment L again and it would become 2, and we would decrement R and it would become 2 again. So now this is a special condition where we need to stop the while loop because L is clearly not less than R. It has become equal to R. So we come out of the loop as it is written here, and we just return the input string here. That is what we do. Yeah. Now, so because this is a very small word, we have gotten it in 2 steps. But if it was like a huge word like, I don't know, Mississippi or something like that, you would get many steps and many iterations of the while loop and incrementing L and decrementing. So yeah, this is a very basic example of that. Now let us see how we can code it. Yeah, now let us code this. This is like a lead code problem. As I've mentioned before, when you come across a problem, you just don't directly jump into the writing the code, right? You first read the question, analyze what the logic could be, and then write pseudo code for it, which we've already written, and then dry run it, which we've already done. So we are all good to code now. So let us read. Now that we know the input here is HELLO, it is basically a character array, right? So if you're familiar with C language, you might know that there's no such thing as string in C. We it is called as a character array. So that's what it is. an array which is filled with characters. How do you know that it is a character? It is enclosed within a double quotes. So yeah, it is HELLO, and we need to get the reversal of this, which is LOLEH. Right? So yeah, let us code this. What did we first need to do? What was the first step we did while uh, dry running the problem, which is initialize the left and right pointers. To do that, we need to first declare a variable from which we can find the size of the input string. Don't get scared by seeing this vector and character, whatever it is here. Just know that it is how we declare characters in C++. Don't focus too much on the syntax part of it. Just try to learn the logic. So we forgot to read a most important part here, which is given here is you must do this with by modifying the input array in place with a big O of one extra memory. So what it basically means is you cannot use or declare an extra array for reversing it. You just need to modify the input array itself so that you don't end up using more space than which is allotted for this problem. Don't worry about this 0 and big O and 1. We will be covering it in the later session. So yeah, let us get into the coding. Now let me just declare a variable called int, which will be the length of the input string. So the input string here is s, right? Since the argument is s, you can also change it. So it's just, it could be anything. It could be ARR, it could be str, whatever. And then s of size. It is an inbuilt function in C. Size is an inbuilt function in C++. So this is how you get the size of the input array. Okay, and then we initialize the left and right pointers. So we initialize left with O because we need to traverse the array from the beginning, and then we initialize R with n minus 1. Let me just make it a little more readable here. Let me just give the spaces. So yeah, put the semicolon here. So yeah, we have the pointers now. Now let us go back to the pseudocode. Yeah, now we need to implement a while loop which would swap both the numbers. Okay. Yeah, let us go back to this, and yeah, let us do a while loop while L is strictly less than R. Mm, Let us take, since we are dealing with character, we can declare a temp variable which is character and assign it with, let me just use another step, and temp, and it is assigned with the value of L. Yeah, L. And then this is how you access elements in an array. So here L would be, since it is beginning with 0, it would be 0 here, and it is how you access the elements of a string. Basically, that's all you need to know here. And then we assign the value of s of L with s of R, and then we assign the value of temp to R again. And since if we just, and then we need to increment L and decrement R, since we've already seen Y in the pseudocode. And then we need to just simply return the input string. You don't need to return anything actually because it is void here. Now let us try. Let me just see the test cases. So yeah, we have two cases here, and yeah, let me just run this code now. Let us run it. see if I've gotten the right answer. Yeah, we have achieved the desired output, and yeah, that is how you do reversal of an array, reversal of a string. So you might also be familiar with the concept of a palindrome, which is if even if you reverse a number or a string, if it is the same, it is called a palindrome, right? Let me take the example of like 101, right? If even if you reverse it, it will be 101. And if you take the if you want to if you want me to be specific with the example of a string, we can take lol. I'm sure most of you use it very commonly. Even if you reverse it, it is still lol, right? So that is a palindrome. So what do you do? How do you find if a string is palindrome or not? So yeah, I'm sure you're beginning to connect the logic of this code with palindrome, right? You just need to find the reverse of the string and then compare it with the original string. If it is equal, then it is a palindrome. If it is not equal, then it is not a palindrome. So yeah, that would be your assignment practice problem. It is in the GitHub repository. We'll be sharing with you this repository's link. Yeah, try it out for yourself and see if you can get it. You can if you have any doubts, you can post it in the comment sections of this video, and we'll be clarifying them in the next Saturday's session. Yeah, I hope you will be able to do any problems on reversal of strings, and you would continue to explore strings. So let us move on to a very important topic in DSA now. That is time and space complexity. What is time and space complexity? So, there are many different ways of solving a problem. You might think one way, you might get an idea of solving a problem one way, and your friend might end up solving it another way. So there's no particular method to solve a problem, right? As long as you get the answer, anything is fine. But how do you know which is a more effective solution, an optimal solution? So this is where time and space complexity comes into play. They determine how accurate and efficient your solution is. These are the most fundamental metrics used to evaluate the performance of your algorithms. So if you're competing in like a lead code contest or a code chef contest, your solution will be judged based on its optimality, right? How how efficient it is, how fast does it give the solution. So yeah, that is the introduction of it. Let us get deeper into what is time complexity. So when you write a program, you want to know how fast or slow it runs, right? Imagine you wrote a problem for adding two numbers, and you're sitting there waiting for an hour to get the. That's not very great, right? That doesn't reflect your programming skills very greatly. So, this is where you can use time complexity. It is a way to measure how the time your program takes grows as the input grows. So, what it basically means is, if you give it this much, like if I give a problem, say one input, how long will it take? If I give it like 10,000 as an input, how long will it take? See, let us say we have to input an array to find its size or whatever. If you've written a function for finding the size of array, and you need to input an array there. Imagine you just gave an array which has only one element in it. It will run very fast, right? You just need to return one. That is the size of your array. What if your array has like 10,000 elements in it? How long will your program take? That is calculated by time complexity. So it's basically like asking your computer or your program, if I give you more data, how much longer will it take you to solve the problem and give me the result? So yeah. So we need to make sure that no matter how big your input is, your program is taking a reasonable amount of time instead of like an abnormally large amount of time. So yeah. These are the methods to calculate the time complexity. It is basically the measure of how much time your algorithm takes as a function of the size of input. And in your classes, you will be taught about the asymptotic notation about it and how do you derive it. It's like you'll have a whole page of derivations on how to get the time complexity of a particular algorithm. We won't be getting into all the theory stuff of it. We just need to know how to calculate the basic time complexities, right? Here are some of the common time complexities. It is read as big O of 1, constant time. If your algorithm takes same amount of time, no matter how large the input is. If you give 10,000, 10 lakhs, whatever, if it takes the same amount of time, it is called as constant time. If your time grows directly with the size of input, it is called as linear time. And if your time grows much smaller as the input size increases, it is algorithmic time. So yeah, that and the quadratic time grows with this like as a factor of square root. If your input is like a, your time will grow as a square, a square, a power 4, like that. That's why it's called quadratic time. Now let us look at an example. Let us look at a pseudo code of adding two numbers. What do you do? Here is the function, and then you just perform one operation, adding it, right? The thing is, no matter how large the numbers are, if it is like float number or an integer, no matter what, we only do one operation, single line of code, right? So no matter how large they are, it takes a constant time to compute sum. So the time complexity is big O of 1. It is constant time. And let us look at what happens when you add two matrices. See, let us take two matrices which have m rows and n columns. As you know, we can only add matrices when they have similar number of rows and columns. It is like one of the rules of matrix addition. And then you have a new array, new matrix, which would be like the which is which would be the result, the sum of A and B. And so we would loop. We are using two loops to add two matrices here. What it means is to access every element in the two matrices, we need to use two arrays. I mean, two for loops. So yeah, what will be the time complexity in such a case, right? A for loop within a for loop. Will it increase or will it decrease? Let us see. So yeah, we know that the number of rows is 1 to m and the number of columns is 1 to n. So for every row, for every m, this for loop will run n times. So if when I is 1, it will run n times. When I is 2, it will run n times again, and up this will go on till I is incremented to m. That means you can do the basic multiplication and we would get that this piece of code will run m by n times, that is m into n times, m into n times, right? So that is a huge number of times that this program is running. So yeah, since we will be running the loops as m by m into n iterations times, the complexity will be a big O of m into n. So you might have a doubt that we are also declaring numbers, and we might also do like an addition, like we are also doing this operation. Why are we only using this operations? Why are we ignoring everything else? See, when you're let us suppose you have a number which is n square, which is a huge number, and if you add 1 to it, it would still be a quadratic, right? So it would still come under the time complexity of a quadratic. So why are we calling it a quadratic when it is m by n? Because we can take a square matrix which has both same number of rows and columns, and it would be n square. So it would fall into the cat. It looks like, oh, it is like quadratic, right? Since we have seen it here, big O of n square, so we are calling it as quadratic n square. So yeah, and just make sure that your time complexity always falls in between like log n and n, even though some cases it is uh, inevitable to get more time complexity. But the whole point of using an algorithm is to reduce the time complexity and increase the efficiency of your code. So yeah, many platforms like LeetCode and CodeChef might not even consider your like your program, your solution, whatever, if it is in the complexity of n square. So you need to be mindful of that. So yeah, this is about time complexity. I hope you've understood how we calculate it and what are the different types of it. So yeah, this is all you need to know to just get started on your coding journey of DSA if you want to start. You don't need to know all the derivations and the mathematical equations behind it. Just the simple thing you need to know. And then let us get into space complexity. What is it? It's all about how much space your program needs to run. It is also a function of your input. That means what if you give this much amount of input, what will be the space required to run the program? That is what space complexity is. See, we have written it. It is a measure of the amount of memory an algorithm uses as a function of the size of input. So when we are analyzing space complexity, we are interested in two types of memories: fixed memory and dynamic memory. So fixed memory is used with fixed memories, which is like static. It doesn't move, it doesn't change anything. So it is called it is mostly used for variables declaration, constant declaration, etc. And the next part is dynamic memory. It's like dynamic memory is a thing that changes with your input. See, like arrays, lists, maybe like a dictionary. See, if you are inputting an array, it could be of any length, right? It changes uh, based on your test case, based on what your desired output, it changes. So it is called as dynamic memory. Yeah, that is what these are. Mm. So yeah, we need to be careful about dynamic memory in C language because arrays are it is a static memory language. You don't really use dynamic memory there, so they don't get confused with that. So yeah, let us see an example. So this is the pseudocode of finding maximum in a list or an array. So what we did here, we have assigned the max value with the first element of the array. And then we have used a for loop to traverse through the array, which is the numbers, which is given here as numbers. And then if a particular number, let us start with 1. I mean, we usually start with 0, right? And if this number is greater than max value, obviously then it would be the next max. So we repeat this until we traverse the whole array, and then we get a max value, which would be the maximum of the array. And yeah, so this is the complexity analysis of this thing, of this particular pseudocode. We are only using a single variable, right, max, to keep track of the largest number. So the amount of memory used by this algorithm doesn't change with the size of its input. So the space complexity is big O of 1, which is a constant space. So let us take another example, which is an so it is linear space complexity. What is a linear space complexity? An algorithm with big O of n space complexity, which is linear space complexity, uses memory that only grows linearly. That means it grows in direct proportion with your input size. This usually happens when you have a data structure like array, list, etc. Right? Because you will be inputting your array value, your list value in Python, and maybe like a dictionary, a linked list, etc. So we have a function which is for storing numbers, storing the squares of numbers, right? We've declared an array here, an empty array which is called squares, and then we are traversing through numbers, which is an array or a list, you can say it, and then we are squaring each number in this list, and then we are adding it to the squares array. So we do this throughout the array, like as long as how many ever elements are there throughout the length of the list. So if the length of the list is n, then you will have traversed, then the loop will run for n times. So you will require n size of space to run this program, because you need to multiply it and then store it n times, right? Because since we have n numbers in the list, we'll get n squares of it. So that's why the space complexity of this is big of n. So yeah, these are the basics of space complexity. And we also have like similar to time complexity, we also have quadratic space complexity and logarithmic. Based on the output program, you get that. Okay, I hope you understood the very basics of time and space complexity, and I hope you would be able to utilize it and apply it in all the programs you solve. So yeah, let us move on to quicksort. What is quicksort? Just a second. So, quick sort. Before getting into quick sort, in the previous sessions, we have used functions like sort to just sort the array, right? And then let us sorting an array is an important method in DSA. We have many different algorithms to sort an array or a linked list or any data structure. So we have different algorithms like quick sort, merge sort, bubble sort, heap sort, etc. But today we'll be covering quick sort. So what exactly is quick sort? Quick sort is a divide and conquer algorithm for sorting a list or an array. Okay, it is a particular divide and conquer basically means that you divide the problem into sub problems, and then and then that's how you solve the that's how you approach the problem, right? You divide the problem into sub problems, then you solve the sub problems, and then the whole problem gets solved. This is called divide and conquer. So yeah, this is what divide and conquer is. So this works by selecting a pivot. What is a pivot? It's just an element which you can select which is like a process here, and then we partition the array to two subarrays. One subarray contains all the elements which are less than the pivot element which we have selected, and the other subarray contains all the elements which are greater than the pivot. And then it recursively sorts, and then we go on dividing the subarrays till the subarray length is 1. And yeah, let us get into the very details of it. Okay, so yeah, steps of quicksort. First, we need to pick a pivot. Choose an element from the array as a pivot. So it can be any element. So you will be given an array and you just need to pick a pivot first. See, different strategies can be used to pick a pivot, as I've mentioned, such as selecting the first element. This is important point. You can select the pivot as first element, the last element, and a random element or a middle element. But the choice of pivot clearly affects your efficiency. So be mindful of choosing a pivot. Okay. And then partitioning the array. So as soon as what happens is you just pick a pivot and then you partition the array. We use a function for it to rearrange the array. So what this step does it, since we have picked a pivot, we just need to divide the array into subarrays now. So what this particular step does is it arranges the array such that all the elements which are less than pivot are on the left, and all the elements which are greater than pivot are on the right. This is what it does. And it also returns a p index, which we will be getting into later, and then it recursively does this. Okay. So yeah, let us get into the pseudocode of this. So here we have a function which is called quicksort, and it is taking input as an array. It is taking the input of an array, a something called a low and high. So these low and high are both pointers which are basically used to traverse the array and check. So yeah, we'll be getting into that later. So we will be first inputting low and high, and then we check if the low is less than high. Then we get a partition index, right? What does a partition index mean? So we've as we've read here, partition index is nothing but the original position of the pivot. Say there's an array called 3 1 2 4, and 3 is the pivot because it's the first element. We have taken it as pivot. We know that the original position of 3 is at the third position, right? Because it is one, because the elements are clearly 1 2 3 4. So the original position of 3 would be at the index 3. So to place it at that, we need a particular array, a particular index to place our pivot. So that's why we use this partition function to get that. And then after getting the partition function, we'll be dividing it into left and right subarrays. So that's why we mention the range of how we do it here: low to p index minus 1, and then p index plus 1 and high. So yeah, that is about this. And then we get into the partition function. So even this takes the input as array low and high, but it is also returning an integer which is p index. So that's why we use it as we mention the type of this function as int. So yeah, first what we do is, since we are taking the first element as pivot, we'd be initializing pivot with the first element, which is uh, so as we know that this low would be initialized to 0 and high would be initialized to the length of the array, which we'll be getting into detail during the try run. We're just looking at the pseudo code now. And then we have initialized it to uh, the lowest element in array. And then we have initialized I and j, two new variables, to low and I. So yeah, let us look at this. What we are doing here is we've used a while loop, then we've used another while. So as long as the array, uh, as an element of an array is less than pivot and it is less than the boundary, this is just the boundary of I minus 1, we can say that we can keep on incrementing it, and then it is the same for j as well, where we decrement it. So this might be similar to the previous reversal of string problem we did, where we incremented the left pointer and decremented the right pointer. It is basically the same thing. And when, as long as, and when we swapped it here, the same, right? Basically like reversing it. And then we used a swap function, and then we used another swap function. So yeah, let us dry run it now. Let me go to the explain draw. Yeah, give me a minute to remove all this. Mm, yeah, let us look at this now. So let us take the example of this array. Let us take the example of this array. So here we have 4, 6, 2, 5, 7, 9, 1 and 3. So yeah, we have two pointers which are low and high, and low is initialized with 0. Low is initialized with 0 and high is initialized with the last element in the array, which is size minus 1. And yeah, that's how we do this. So yeah, and let us do the same thing what we did in the pseudo code here as well. So what we did is we selected 4 as pivot, right? Let me just write this as pivot. So yeah, now what we do is we start comparing pivot with all the other elements. Since oh yeah, we have this, let me just copy this here. Let me just copy this piece of code so it is better for you to understand it. So yeah, Let me just move it around a bit. Yeah. So what we're doing is, first we need to check. So yeah, now we have low is equal to I and high is equal to j, right? So what we're doing here is, as long as I is less than j. So now I here is at 0 and j here is at 7. So clearly it is the condition is satisfied. So we go into the loop, and here we have another while loop. So what it says here is, array of ARR of I is less than pivot. As long as it is less than or equal to pivot and it is less than I minus 1, we increment I. Okay. So let us see that. And here we have ARR of I as 4 and pivot is also 4. So it is clearly less than, the condition is satisfied, and I is also less than high minus 1, which here is 7 minus 1. Okay, let me just write it down. Okay, high is equals to 0, which is less than 7 minus 1, which is equals to 6. So the condition is satisfied, we move on, and now the I is equals to 1, since we incremented it. So I moves here now. Okay, the I moves forward. Now we check the condition again, right? If is array, is the new element less than pivot or not? The new element is 6 clearly, and it is not less than 4. So what do? Is we stop and go to the next loop. Since it is not satisfied, we move on to the next loop. Here we check if the jth element ARR of j is greater than pivot. So let us move here. We have j here at 7, and a of j is 3, which is clearly not greater than pivot, which is, let me just write it down here for your better understanding. Uh, Let me write it down here. Yeah, j is equals to 7 here. So yeah, ARR of j is equals to 3, which is less than 4, right? It's not greater than 4. So this condition is not satisfied, so we don't go into the while loop here, and we go and check this if statement here. So what does it say here? Is I less than j? So our current I value is 1 and our current j value is 7. So we swap both we swap the numbers which are in I and j's positions. So we swap here 6 and 4. So we get a new array where 6 and 3 are swapped and 4 remains the pivot, right? So yeah, let me just write the new array here. So the new array would be 4 and 4, 3, 2, 5, 7, 9, 1 and 6, right? So this, so our I is here, our I is here, and our j, where is our j? And our j is clearly at 6. Okay, yeah, I is at 3 and j is at 6. So yeah, we check this condition again. If 3 is less than pivot, yes it is. And so we go into the loop where I is incremented, so I moves forward. And we check if a of j is greater than pivot, which it is. 6 is greater than 4, so we increment j, decrement it, so it moves to 1. Okay, now we check Now we go back to this loop again, and then we check if I. So since we are at here now, 2 is less than 4, right? So this condition is satisfied again. Let me write it here again. Now I ARR of I is equals to 2, which is less than pivot. It is also less than 6, high minus 1. So we don't get any out of bound errors. So yeah. Mm. So we go into this loop, and then let me just copy this, copy it, then I'll paste it here. Okay. So yeah. So since I is at sorry, yeah, J is at 6, right? Uh, Let me just move I. So I is clearly less than 4. So we increment I now. I would be at 5. But 5 is greater than pivot. So the condition is not satisfied. So we go to the next loop, which deals with the j side of elements, which is like the right pointer. So what happens here is the pivot is less than this 6. So we just go into this loop because the condition is satisfied, and this is where j is now. As we can see that j is clearly a of j is clearly not greater than pivot, right? uh, See, 1 is less than 4. In fact, it is not greater than 4. So we need to swap both I and j. So what will be the new array we get? We get an array where both 5 and 1 are swapped. So yeah, let me write the array here again. 4 3 sorry 3 2 5 7. Sorry, the 1 is swapped here, right? So 7 9 and 5, and then 6. Let me just move it up here. Hmm. So, yeah, so we have swapped I and j, right? So the new I would be here, and j would be here. Since we did that, we can check the condition again, and we find that 1 is less than 4. So we just simply need to move I again, and we go to the next statement, and here clearly I is greater j is greater than 4. The number which is at j is greater than 4. So we decrement it. Here it is still greater than 4, so we decrement it again. It is still greater, and then we decrement it again. So as we can see here now that our this condition is failing, right? This condition is failing. So we need to come out of this loop and perform this operation. Here we know that we need to swap array of low, which is basically pivot, right? 4. Here we've declared it already, right? We have declared array of low as pivot. So we need to swap array of low and the latest value of j. So the next array we get would be like this. It would be 1, let me just 1 3 4, 1 2 3 4, and 7 9 5 and 6. So we can see that now we've completed the second part of the steps of quicksort, right? We have arranged the numbers which are less than 4 at the left side of it and greater than 4 at the right side of it. So we are base half done with this problem. So what do we need to do next is, let me just go back to the pseudocode, right? Now we have two subarrays. What do we do to get it sorted? We apply the quicksort function again here. That's why we mentioned it as recursively apply the process to the subarrays. So now the range we've taken here would make sense to you, right? It is low to p index minus 1. P index is a value, is the original correct value of 4. What is correct value of 4? See, let me just put it in a very simple way. We have the array as 4 3 2 5 7 9 1 6, right? What if I just sort it? It would be 1 2 3 4 5 6 7 and 9, right? So we got uh we got one number which is exactly as it should be, and it is a pivot element. So the first step is done. Now we need to get into the subarrays. The subarrays here are 132 and 7952, and this we need to do the same process for the subarrays as well. Here we'll be taking one as pivot, and then we check it, move it here, and then it is not greater, and then we go to the next, which is, this is a greater, and then we go here, which is clearly the condition is not satisfied, so we swap both of these numbers, and then we get like 1 2 3 as it, and we have 4. And in the similar way we can use pivot as 7, and like do all of this process here which we did. And now, so 7, right? 7 is pivot here now, and we check if 7 is less than 7, the condition is true, so we increment I, and 9 is not less than 7, it is greater than 7, so we go to the jth element. Here it should be greater than, right? But it is less than 7, so we swap 9 and 6. What will we get here? So we get here 7 6 5 and 9. So clearly our I is here and our j is here. J is here. So I is less than 7. 6 is less than 7. So we move forward, which is 5. We also move forward again because it is still less than 7, and the condition is satisfied here again. So 7 is in the position as 9 is in the position as it should be. So we only take this subarray now, and it would be sorted. And if we take only this subarray here, and we get the sorted array by repeating all these steps again. So yeah, the sorted array would be like this. As you can see, we have achieved our desired output, which is sorting this array 7 and 9 by applying the steps of this. So let me recap what we did. So we chose a pivot first, right? We chose a pivot, then we got the pivot into its original position. Then we applied the same process on in its subarrays as well. We sorted this subarray, and then we sorted this subarray, and then we got an array which is fully sorted using quicksort. So this is how you approach quicksort, and this is the algorithm, all the steps you do. So let me go back to the repository now. So you might get a doubt that why do you need to use quicksort when there is merge sort, bubble sort, and all these different types of sorting algorithms, right? The main reason for using quicksort is we don't need an extra array to do it. We just modify the input array itself to change it. So we'll be saving a lot of space. So it is optimally the time complexity is very less compared to merge sort or bubble sort. So that's why we use quicksort. So yeah, as we mentioned before, now we've analyzed the problem. Uh, and we got down the logic of it, and we got down the pseudocode of it. Now we are all ready to code the problem, right? Let me just go here. Yeah, just a second. So yeah, so what do we do now? First, let us read the problem. What is the problem statement? See, it is saying that you're given an array of integers. You need to sort the array in ascending order using quicksort. So yeah, it is given the description of quicksort here. You can read it if you want, then we recursively do it. Yeah, so here we took, it is like an array of 4, 2, 1, 5, 3. He took 3, the last element as the pivot. Since we have practice of first element, we can do the first element. We can check simultaneously. I'll do a quick try run of this, which is 4. 4 is the pivot. We begin here, I would be here and j would be here, and then 4 is less than the condition satisfies, so it moves forward. 2 is also fine, and then it moves forward, it is also fine, and then 5, it is not greater, right? So we move on to this. mm, so we move on to 3. 3 is less than 4, but it should have been greater than 4 because it is at the rightmost side, right? So we swap both 3 and 5. 3 and 5, and then we decrement j here. It is clearly still less than. We swap 3 and 5, and 5 is in its original position, and then we j is at 3 now. J is at 3 and I is at 1. Then we swap 3 again with 1, and then yeah, that's how you proceed. You can repeat the same process, and then we get 4 here, 4 at the original position, and then we'll be getting 3, 1, 2, 3 before 4, because that's where we get the left subarray, and then we get 5 here at the right subarray. Yeah, that's how you proceed with this. And yeah, let us get into coding this. So here they've given a quick sort array. Don't get confused. We need to return an array here, since it is vector int. This is don't get scared by this vector int and all. It's just the syntax of uh, vector in C++. So yeah, since we need to return a vector here, let us take a function which would do that. So since we have the pseudocode for this, let me look at the pseudocode. We have a quicksort and we will be doing all this, but we did not return anything here, right? Which is directly, it's just like a void function. We did not return anything, we just modified the input. But here you need to return uh, an array. So let me just assume that we have a function called qs, and then this would be taking arr as input. And then if you remember in the pseudocode, we also need to give low and high as inputs. So we need low will be 0 and high will be arr. Let me just arr of size function, since we've already discussed that this is a function to get the size of an array or a list or a string in C++. That's how this is I. We use -1 so it doesn't get out of bound. Yeah, this, let me just assume that we have written the definition of this function for a while. Then we return arr. So let me just assume that this code, that this function, this sorts my array and then we return it. So let us write the definition of this code now. So what do? We just void qs of, we will be passing the vector here. By vector I just mean an array, arr. Then we pass two arguments, int low and int high. Yeah. So let us write the definition of it. What will be the definition of it? Let me just go to the pseudocode. What did we do here? We checked if low is less than high, and then we assigned some value to p index, and then we sorted. Then we used recursion. So let's just do that first, okay? Don't worry about the partition function just yet. Let me just code this first. Just a second. So yeah, since we already have the low and high, I would just use a I will just use an if statement and then just say if low is less than high, move on, and we initialize p index with. Now let us also assume that there's also a function called partition. It will take array as argument and low and high as arguments again. Okay, don't worry about it, we'll be just coding it in just a few seconds, few minutes. Yeah, now we have p index, we have low, we have I, we have everything we need. So what p index, so what we did here is, if you remember, we just placed the pivot in its original position now. Okay, assuming we have a function called partition, we just placed the pivot in its original position. So what did we do next? We figured out the right subarray and the left subarray. The left subarray contained the elements which are less than of the pivot, and right subarray contained elements which are greater than. So that's what we need to do. We need to sort the left subarray and the right subarray separately. So yeah, let me just use this function again. QS and input ARR and low. We are just defining the range, and then P index minus 1. Okay, why minus 1? Because it is the left side of p index, so yeah, that's why. This is the left subarray. Okay, let me just comment it and write it for you. Left subarray, sorry, left subarray. Yeah, let me just sort the right subarray, because that's what we did right here. We positioned the pivot and then we sorted the left subarray. Now we have to sort the right subarray. That is what we're calling. Nothing complicated, right? Don't get scared by all this. Just try to understand the logic. ARR. And what do we do now? We need to consider the elements which are after P, right? We need to do P index plus 1 to high. That's what we did, right? What did I do here? Okay, sorry. My I is also capitalized. Yeah. P index plus 1 to high. Yeah, we got our right subarray as well. So our array now is sorted. We can move on. Okay, now we need to declare the function. We need to give functionality to this partition function, right? So what do you do here exactly? Let me go to the pseudocode pack again. So what did we do here? So the partition function is supposed to return and then the partition function will be returning integer, which is the p index, right? So that is what we'll be doing. And yeah, so let us declare int partition, and it also takes vector, and by vector again I mean array. say array and int low and int high, and then now we'll be initializing declaring the pivot, right? Since we have taken the first element as pivot, we'd be int pivot is equals to arr of low. Why will be taking it as low here? Here we have declared 0 instead of low, so this will be the first element of the array. And then we need to declare two more variables, which are I, which will be equal to low, and then which will be j, which will be equal to high. So yeah, that's it, right? And then we need to use a while loop. And then we check the condition. So while arr of I is less than or equal to pivot, and I is less than or equal to high minus 1, so we don't go out of bound. What do we do now? We increment I. That's what we did in the try run, right? That's all we do here. Yeah, now we declare another while for j. Yeah, as long as array of j is greater than pivot, sorry, and j is less greater than or equal to low plus 1. So we don't have to calculate the zeroth element here, and it doesn't get out of bound. That's why we take plus 1 and minus 1 to ensure that. And yeah, we declare j decrementing it. Yep, that's it. So you might get a doubt that why did we take greater, less than or equal to here and only greater than here? That is because if you have any duplicate values, like if you have had two fours here, then all the elements which are greater than 4, sorry, less than 4 or equal to it will be on the left, in the left subarray. That's why we have given equal to here. Since we have used equal to already here, we cannot use it here also, otherwise we'll get repetition of elements, which would lead to another error. So be mindful of that. Then let's move on. Now that we've incremented and decremented j respectively, now just take a if statement saying that if I is less, after doing all this, if I is still less than j, just swap it. Yeah, we can just use the swap function because it is C++, it has an inbuilt function. It will be swapping a of arr of I comma arr of j. So yeah, if all this condition, now if we after that we just simply swap arr of low comma arr of j. This is the latest swapping of pivot with the latest element of j, right? When it has crossed j. If we do this in case j is crossed the limits of I and it is now less than I, so we cannot go into this while loop anymore. So we simply swap it with pivot element, and then we return j. This would be a pivot index. So yeah, let me just run this code now. Yeah, and we've passed all the test cases. Yeah, so the array input array was 42513, and we got the sorted array here. Same for this example as well, and there are three cases like this. So yeah, that is how you do the quick sort algorithm. So let us move on to the last problem of this session now, which is sorting zeros, ones, and twos. This is also called as is the Dutch national flag problem, because it also has like three colors in it, and it was introduced by Edgar Dikshitra, And this problem involves sorting an array which has three categories of numbers, which is one, 0, and 2. So yeah, so when you look at this problem, and it's yeah, sort colors. So if you look at the input of this problem, your first idea after solving quicksort would be to just sort it off, right? So, so yeah, that is a good thought process. But the thing is, if you use quick sort for uh, an array which has so many duplicates, the thing is, you would get the time complexity of it as log n, big O of n into log n. But if you approach, you might want to approach it, maybe there's a method out there which would reduce the time complexity, right? So yeah, let us look at such method. Yeah, let me just yeah, let us look at the problem statement. So all the zeros have to appear first, then preceded by ones, and then preceded by twos. Okay. So this is a pseudocode. We have a function called sort, and it takes an array of zeros, ones, and twos as input, and then we calculate the size of it, and then we have three variables which can be called as counters, which is zero, c of zero, c of one, and c of two for the same for ones and twos and zeros, and they're initialized to zero. So we take a for loop, and then from the array we traverse the array, and if the particular element of array is 0, we increment c0. If it is 1, we increment c1, and if it is c2, we increment, if it is 2, we increment c2, right? So yeah, that is the whole logic behind this. And then we print it, right? We take an additional variable which is idx, which can be called as index. So why do you need to take an index value instead of printing I? The thing is, we need to first print zeros, right? So we'll be printing zeros up until the count of c0. So what happens after this is, if you just print I value, it would again print from first. So it won't be like a continuous value of zeros, ones, and twos. So if we use a particular index for that, it will keep track of where the range of zero ends and where the range of one start. So yeah, that is basically the idea behind this pseudocode. So yeah, the time complexity of this, since we have an array of n size, it would be big O of n. So which is much better than n into log n, right? So that's why we use this approach to the problem instead of using quick sort approach. So yeah, let us go to the code part of it. So yeah, we take the input and yeah, let us code it now. Okay, since we already did the dry run. So, so we have an array. So we have a function which would take uh, an array as an input. And yeah, what did we do first? We took the size of it, array of size. So let us go to the pseudocode for a minute. And yeah, so we took the size of it, and then we declared three variables, which are c0 is equals to 0, and c1 is equals to 0, and c2 is equals to 0. Okay, and then we just identify zeros, ones, and twos in the arrays, and increment the respective counter. Okay, let us take a for loop. int uh, int I is equals to 0, I less than n, which is the size of the array, then I plus plus. Yeah, so if arr of I is equals to uh, is equal to, this is like the equal to operator which we have covered in the first session. If it is equal to 0, then we increment c0, which is 1. Maybe just we'll just use this for this. Yeah. is equals to 1. This is the increment operator, which C will be C naught will be incremented, and then it would be reassigned to C naught. So instead of C naught, now C naught 0 and C naught would be 1. The same, let me just copy this code. Yeah, I'll just type it off. Else if we are taking a ladder of ifs. So yeah, else if ARR is equal to 1, and if, sorry, then C1 will be equal to incremented, same as the above process. And then we have the last case, so we can just use else for that, and then we do the same incrementing. So so we come out of the loop now, and then we take an int, take a new variable and initialize it to 0, and then we print all the elements. Now we take another for loop, int I is equals to 0, and here we'll be placing the range of it as C naught, and then incrementing it again, and then uh, we access this and then equate it to zeros, right? Then we do the same for the rest. Let me just copy this and change C1 here, C2 here, 1 here, and 2 here. See, I have already explained the purpose of this index to keep track of the range of zeros and ones and twos. Yeah. So let us run this program. So yeah, we passed all the test cases. So yeah, that is how you sort an array which is of zeros, ones, and twos. It might not always be given in this way. You can also get the since you see this problem is called sort colors, right? So you can be given an array of like red, white, blue balls, and you're supposed to sort them with like a particular order. Then you can then this problem would be an application of this approach. So yeah, I hope you understood that. And this is also called as Dutch what is it? Yeah. It's also called as Dutch national flag problem because it has like three colors in it. It's like basically for all the categorical types of problems. So yeah, that's how we solved it and we passed the test cases. Yeah. I hope you understand the logic behind this problem. So yeah, just because the problem has sort in it, you don't need always need to go with quick sort or any other sorting algorithm. Just think, is there another way to reduce the time complexity of it, right? Then just think innovatively, creatively, and come with your own solutions. So yeah, that's it for today's session, guys. I hope you learned something. I hope you understood all the logics. So today we covered like a lot of topics, right? Strings, reversal of string, time and space complexity, quick sort, and then sorting this, right? So if you've stuck to the end and followed every problem, kudos to you. So yeah, we'll be seeing you next Saturday, and with this, we'll be closing today's session. Thank you.